What is the value of the yellow region? Line constructions, cosine rule, trigonometric identity, Pythagoras' theorem, basic arithmetic and algebraic processes are used to solve this question. Label the centers of the circles O, C, and G. Join line OG. Also, label points B, D, and K. Line OB equals to 3. It is the radius of the largest circle. Line CG equals the sum of 2 and 2.5, which equals to 4.5. From triangle COG, using Pythagoras' theorem, the square of line OG equals the sum of the square of line OC and the square of line CG, which equals to 50.5, after simplification of substituted values. This implies that the square of line OG equals 50.5. We call it equation 1. Join line OK and label point P. Also, join line PG equals line DK. It is because the opposite side length of a rectangle are equal. Since DG equals KP, which equals to 2. The same reason as above. It signify that line OP equals line OK minus line KP, which equals to 3 minus 2. The result is equals to 1. From right triangle POG, using Pythagoras' theorem, the square of line PG equals the square of line OG minus the square of line OP. Substitute equation 1 and value of line OP. This implies that the square of line PG equals the square of 50.1 minus the square of 1, which equals to 49.5. Take the square root of the equation. This implies that line PG equals 49.5. Since line PG equals line DK, hence line PG equals the square root of 49.5. We call it equation 2. Let us find the value of angle KOB. Let angle KOG equals theta and angle COG equals alpha. From right triangle COG, by trigonometric identity, line CG divided by line OG equals 4.5 divided by the square root of 50.5, which equals to sine theta. This implies that theta equals sine inverse 4.5 divided by the square root of 50.5. which approximately equals to 39.2894 degrees. Consider triangle POG. By trigonometric identity, PG divided by OG equals 49.5 divided by 50.5, which equals to sine alpha. Find the sine inverse of the equation. This implies that alpha equals sine inverse of the square root of 49.5 divided by 50.5, which approximately equals to 81.9105 degrees. Hence, The sum of theta and alpha approximately equals to 39.2894 degrees plus 81.9105 degrees. That is 121.1999 degrees, which equals to 121.2 degrees to 1 decimal place. Since OK equals OB, which equals the radius of the largest circle, KOB is an isosceles triangle. This implies that angle OK, B equals angle OBK, which equals half of 180 degrees minus angle K, OB. The result equals to 29.4 degrees. After simplification of values. Hence, angle BKD equals angle OK, D minus angle OKB, which equals 60.6 degrees. We call it equation 3. Let us find the length of BK from triangle BOK. Using cosine rule, the square of BK equals 2 times the product of square OB and 1 minus cosine angle KOB, which equals 18 times 1 minus cosine 121.2 degrees. Take the square root of the equation. This implies that BK equals the square root of 18 times, in bracket, 1 minus cosine 121.2 degrees, which approximately equals to 5.2272828667. Hence, area of triangle KBD equals half the product of BK and DK times sine 60.6 degrees, which approximately equals to 16.020400069 square units. After simplification of substituted values. Therefore, the required yellow area equals 16.02 square to 2 decimal places.